All right, could everybody hear me now? Assuming, yeah. All righty, perfect. All right. So how's everybody doing? Oh, let me mute my Twitch. Okay, perfect. All righty. I'm just gonna wait up a bit. We're gonna start in like 2-ish minutes. So how is everybody's week going? Oh, crap. There's. That's good. That's good. Well, it's good also. Not that bad, to be honest with you. Could be better. But yeah. So is everybody here taking 393 or and any NGs in the chat that already took 125? Or it doesn't really matter. Comp eng, perfect. Cool. Alrighty. Let's get started now. So we're gonna be talking about pointers. I personally love pointers. I love abusing pointers. I love using pointers everywhere. So really the description of this workshop is pointers, manual memory management in C and C++. Get ready, grab your favorite IDE, compiler, and a stress ball. A stress ball is a must when dealing with compilers, especially when you make dumb mistakes, which I do a lot, and you get those segmentation faults. But yeah, so pointers are fun, and yeah, let's jump right into it. So here's a quick intro to pointers. All right. So pointers is a pointer is a variable which contains the address of another variable. And it's that by address, I mean the memory address. So most of you guys, whoever took CPS 125, so computer engineers already are introduced to pointers, and people in second year comp sci taking 393 are also introduced about the concept of pointers in memory. But we're going to do a quick refresher just in case. So people talk about how pointers are dangerous. But to be honest with you, like they are dangerous if you misuse them. And I want to quote a very good book, and I guess everybody here should know this book. So it's the C Programming Language by Brian Kernighan and Dennis Ritchie right here. It's a really good read. Funny thing, I'm actually wearing the shirt right now. Yeah. Anyways, yeah. So I'm going to read this quote, and I like this is one of the best quotes about pointers and everything. Oh, where's the C++? Don't worry about that. If you guys want, I do have a shirt of C++ somewhere. Maybe it's, I'm not sure. I'll look for it. Maybe some other time. But yeah, so pointers have been lumped with go-to statements as a marvelous way to create impossible to understand programs. This is certainly true when they are used carelessly, and it is easy to create pointers that point somewhere unexpected. With discipline, however, pointers could be used to achieve clarity and simplicity. And that's the most important thing that you need to know and be careful when you're using pointers. They are very powerful, but they're also dangerous at the same time. So it's a double-edged sword. All right, so let's talk about memory and addresses and how memory is laid out. So I drew this diagram. So sorry, I couldn't find a proper diagram online, so I just decided to draw one. So let's say that memory is organized like an array of cells, which are numbered or labeled as addresses. So as you can see, actually, I'm not sure if you guys can see my mouse, but so right here, these are the memory addresses of each cell. And they're just numbered. I've numbered them in hex. Why not? So, okay, yeah, perfect. You can see my mouse. So yeah, so let's say we have a variable, C, which is a character, and we initialized it as A, and C is located right here. So in memory location F2, as you can see right here. And let's say that we also have a pointer, which we initialized it to have the address of where C is located, so F2. So as you can see right here, we have a pointer at address 2, but inside that pointer, there's the address of the variable C located in it. And that's pretty much what a pointer is. It's just a place where something points to the memory. That's basically it. So how do we declare and use pointers? Actually, before I get started, does anybody have any questions about the diagram or anything? Mirror that tier diagram. All right, yeah, well, I learned from the best. Well, okay, assuming there's no questions, I'll continue. So how do we declare and use pointers? So we declare pointers with an asterisk or a star symbol. And to do that, here's a quick example. We simply just use the variable type name, so an integer, let's say, and do an asterisk p. So right here we declared a pointer to an integer, and we call that a pointer to an integer. And then let's say we want to get the memory address of a variable. So let's say we want to initialize that pointer with the memory address of another variable. We could use the ampersand or that and symbol. And here's a quick example. So let's say we declare an integer I, and we initialize it with 1, 2, 3. As you can see in line 2 right here, this does nothing, but I'm just showing you how to use the ampersand, and that's how you use it. And this actually gives you the memory address where I is located. So there's two methods to declare and initialize a pointer. What you could do is do integer asterisk p equals to the ampersand I, and that initializes the pointer to the address where I is located. Or there's the method 2, where you use an integer asterisk p, and then you do p equals to ampersand I. And I'll go into when to use the asterisks and use it always in declarations. But I'll explain to you why we're not using it here and when to use it outside of declarations. So I'm assuming here everybody should be good with this, assuming that everybody has some basic knowledge about pointers. All right, I'll continue. So let's talk about dereferencing a pointer. And dereferencing a pointer really just means it's the value of the variable where the pointer points to, and that's how you dereference it. So use the asterisk symbol again, and do not mistake the asterisk symbol. You could use it in dereferencing a pointer, and you could use it when declaring a pointer. But you use the asterisk symbol to also dereference the pointer. So here's a quick example. Same example, we have integer I is equal to 1, 2, 3. And then we declared a pointer and we initialize it to the address of I. And then now let's say we want to make another integer and store the value, store a value to that integer with what pointer p points to. So all we do is integer a is equal to, we dereference it, p equals to p. And that gives me 1, 2, 3. So 1, 2, 3 is now stored into a. Let me give you a quick visual example, and here's me printing it out, let's say. So me printing out the pointer right here. This is just the people that have not done C++ yet, or that are in engineering and they don't do C++. This is basically me printing it out to the console. So here, me printing it out without dereferencing it. What I get is I get the memory address. So I get it right here in hex, and this is the address where the pointer points to. It's not the address of the pointer, it's the address of where the pointer points to. So the address of I in that case. So what we do here is if we want to dereference it and see where P points to, what we do is we just dereference it and put an asterisk. And right here, if we do this, it prints 1, 2, 3. And that's the value of the variable at the memory address of this right here, or right there. But yeah, so let's talk about, after we did, but let me go back to actually dereferencing pointers, sorry. Yeah. So does everybody here understand what's going on with this? I'm just making sure. All right, so I'm going to jump into the next slide. So we have something called a null pointer. And a null pointer is a pointer with a value of 0, or let's say a pointer that points nowhere. So that pointer could be used as a placeholder. And here's a quick example to a null pointer. So to initialize a null pointer, we could do an integer asterisk p is equal to 0. And note that 0 is the only integer we can point the pointer to. And that gives it and makes it a null pointer. We could also do equals to null in all caps. And the last one, so in line 3 right here, equals to null pointer, that is only available in C++, not in C. But all of these work in C++, except for the last one. The third one does not work in C. It's only in C++. So the point of, let's say you want to null, sometimes you're nulling a pointer out because you're done with it, you don't need it anymore, or sometimes you want to use it later. So here's a quick example. So we could just do an integer I. Let's say we used either one of these. It doesn't matter which one we used. And we got a variable of I, and we just want to point the pointer to I. And all we do is do P equals to ampersand I. And that's pretty much like null pointers. So why even use pointers? And this is something that people really, when you understand when you should use pointers and when you shouldn't, you unlock the power of pointers. So one example is function arguments, and this is mostly in C and C++. So efficiency gives you the efficiency when passing variables. So let's say we pass a variable into a function. When we pass a variable into a function normally, one sec, let's see. Does the null pointer have any special use case? Yes, it does. I'm assuming everybody here, so let's say the people in CS are taking data structures right now, and the people in Eng are taking data structures next semester, but they already done linked lists. So null pointers are going to be useful in linked lists, and we're going to talk about them. Actually, we're going to be doing some examples with linked lists. So yeah, so the special use, let's say you want to free up like you want to null out a pointer because there's no need for that pointer anymore. Or let's say you have a linked list and you want to delete, like let's say delete the last, let's say delete the next node in the linked list. All you do is just do, let's say linked list next equals to null pointer, because that would be pointing somewhere. That's an example of use in linked list, and I'll be showing more examples of it. But yeah, so I hope I answered your question. Not sure if I did. Okay, perfect. So it gives us the efficiency when passing variables. So when we pass a variable to a function, it is copied. By that, when it is copied, it is allocating a memory for that copied variable. So let's say we initialize the pointer outside of the scope of the function. We already allocated memory for that variable. But then when we pass it into a function normally without using pointers or references, right here we copied it. So we also allocated memory for the variable again. Therefore, we used memory that we don't need to use. So here's a quick example. All right, so let's say I have a function, a void function called fun. And we pass it int A and int B, and it does something with them. We really don't care what it does with them. It's just we're just looking at the arguments. And right here, we're assuming that it's a 32-bit machine. So when we declare x and y, initialize them to 1 and 1, we are allocating 4 bytes for each of them. So when we call function fun and we pass in x and y, when x and y are passed, they are copied into A and B, and we are also allocating 4 bytes for each of them again. So on the stack, we would have so we'd have 4 bytes variables that we really don't need to do, to do that. So here's a quick, so this is a quick example on function arguments. But let's say we want to improve this, and let's say we want to use what we just learned and the pretty basics of pointers to actually make this more efficient. Let me show you guys right here. So how do we improve this? We can pass by it's called pass by pointer. The argument, we pass it by a pointer in C, or pass by reference in C++. Pass by pointer in C++ also works, but if you're using C++, make sure to use pass by reference. It's much more safer. But I'll be showing examples for both of them, and even in the linked list example, I'll go through each one just in case. So here's a quick example. I just wanted to double check something. All right, perfect. Yeah. So here's a quick example. So this is I'm going to start out with talking about C, and then I'll talk about C++. So let's say we have function fun C, and right here the arguments right now we're going to use pointers. So we're going to pass the memory address to them. So right here we declared fun C, and we have an integer, a pointer to A, an integer, a pointer to B. A is a pointer to integer, sorry, and B is a pointer to an integer. And right here, we're doing something. So let's say we're using the variables. We want to store the sum of A and B in C. What we need to make sure when we're passing by pointers and the arguments are passed by pointers, we need to make sure that we're dereferencing the pointer, because it is just a pointer. So we can't use them normally. We can't do A plus B without doing the asterisk or dereferencing it, because at that point we're adding two memory addresses, which would be invalid. So we would need to dereference it to get where it points to get the sum. So right here, let's say when we call func C, and again we have x and y right here. When we call func C, we have to use the ampersand. So we have to use x, ampersand x, and ampersand y. This gives it the memory address. Is there a speed difference between pointer reference? Oh no, there isn't. Just pass by pointer is much safer, and I'll be in the next after two slides, I think, if I'm correct, I'll be telling you guys about the difference between them. But yeah, so if you're using C++, pass by reference is preferred, and I don't think there's there's one use case where you'd use pass by pointer, and I'll go through that also. But yeah, so for func C, what you would need to do is you would pass it by ampersand x and ampersand y, because you need to pass the function the address of x and the address of y. So in this case, the pointer address is passed and nothing is copied. Well, x and y are not copied, but the memory address is copied into here. That's one thing to know also. So we must include the ampersand to get the memory address. On the other hand, when we're using C++, let's say I have a function called funcCpp. In arguments, all we do is we put integer ampersand a, integer ampersand b. That means that a is going to be a reference, so it's going to be a pass by reference. And when we could do something inside the function. Let's say we also want to do the same thing as func, and we want to add a plus b and store the sum into C. We use here the variables normally. We don't need to dereference them. So you don't need to worry about having pointers in your arguments and dereferencing them all the time and making small mistakes like that. So this could be done like that. And when calling it, it makes much more sense to call it like that. So funcCpp x, comma y, and that's when we pass the variable x and y. We don't need to use an ampersand because we're passing it by reference, and it's a reference to the variable that we're passing. So yeah, so we should not include any ampersand, and because we're not passing the memory address, we're just passing a reference to x. And the compiler figures it out all for you. So we really don't need to get the memory address. I'm hoping I'm actually here. Let me go back to it. I'll be posting a PDF of the slides, just in case. One sec. Yeah. So I'm hoping everybody gets this. It's a bit confusing if you're starting out with pointers, but does everybody understand this? And if there's any questions, just let me know. Yeah, and the VOD will be saved afterwards. All right, so I'm going to jump into the next slide. So we're going to use a practical use for pass by pointers or pass by reference. So, all right, so let's use a practical use of that. The easiest one is swapping. So let's say we want to swap two variables. How do we do this with pointers? Here's a quick example. So I'm going to be showing you the first function just to make sure, just so everybody does not get mixed up. The first one from line 1 to line 6 is wrong. I've labeled it swap wrong just in case. But yeah, so right here we made a function and we called it swap wrong. We pass an integer a and integer b, and we're doing all the swap stuff in here, so we don't need to worry too much about it. And when we call swap wrong, we're passing x and y. But as you can see, if we print out x and y, it prints out 1 and it prints out 2, but they are not swapped. So in this case, if you could notice, we did not pass it by pointer or we did not pass it by reference. Therefore, they are copied inside here, and the x and y are not changed. They're just they're just copied inside here, and then whatever is changed in here is inside the scope of the function, and nothing comes out. So this is the some people coming from other languages might find this a bit weird, but this is how it works in C and C++. So this is the correct way to using this. And what we do is we do pass by pointers. So let's say this is the correct swap function. So we have swap, and it accepts a pointer to an integer A and a pointer to integer B. And we do here the swap mechanism, but just to make make sure everybody understand this, that we always need to have we always need to dereference the pointers. Right here, I am not dereferencing temp because temp is declared as an integer, not a pointer to an integer. So when we store, 1 second, let me check chat. Oh, it's all fine. Yeah. So when we store what A is inside temp, we need to dereference it. If we don't dereference it, it's going to give me an error because we are storing a memory address inside an integer, not an integer. But yeah, so just remember to always dereference your arguments when you're passing by pointers. And when we call swap, and this is the C way, or the pass by pointer way, well, the correct way is to pass by pointers. But yeah, so we'd call $x, $y, and right here, when we print them out, they are swapped. So we print out 2 and 1. But yeah, I'm hoping everybody gets this. I didn't explain much inside the function because I didn't think I really needed to, but yeah. Okay, so I'm going to go to the next slide. So the next slide is actually pass by reference. So this is in C++. So this is the C function that we just talked about, and I called it swap C here. But this is this swap C++, and this is the difference between them. So in swap C++, all we do is we put $A and $B. So it's the reference to a reference to an integer and a reference to also an integer B. And here we do the same exact thing that we did inside swap C, but we don't need to dereference them because they're references. So yeah, so that's pretty much how we use it. And we call it normally without the ampersand, and it also swaps them. I hope everybody gets this. So yeah, if there's any questions in chat, let me know. And if I'm going too fast, also let me know. I tend to go sometimes too fast. All right, so here I want to discuss the differences between pass by pointer and pass by reference. So so a pointer can be reassigned, but a reference can't. A pointer can be assigned to null directly, but a reference cannot. So let's say we're calling the swap C function. We could actually call it with a null. We could put null here, or we could put 0, or we could put null pointer, while in a reference we cannot. That's one thing. So and then yeah, so then a pointer, every time we need to access the variable in the memory location, we need to dereference it. With reference, we do not. All right, so let's talk about things to be careful about, because I told you guys that pointers are a bit dangerous. So I'm just going to go over one example because we're still doing the basics. And one example is dereferencing a null pointer. So you'll get a segmentation fault. So here's a quick example. So a segmentation fault is a runtime error. It's not a compile time error. These tend to be hard to debug. So be careful when you're using pointers, because you can have a headache debugging if you're doing something wrong. Let's say dereferencing a null pointer. So here's a quick example. So let's say on line 1, I declared a pointer p to an integer, and that points nowhere. When I print this out by dereferencing it, so I'm trying to get the value where this pointer points to, I get a runtime error and I get a segmentation fault. At that point, this is a runtime error, so the compiler doesn't tell you anything. It's just when you run the application, it crashes. But yeah, so this is dereferencing a location that does not exist. Another example, and I wanted to make this a bit more confusing so we could see how it is used in normal code. Let's say we start here at line 11. So let's say we have an integer a, and we initialize that to 5, and we declare an integer a pointer to an integer p, and now we want to point p to the memory location of a. So we do that in line 13. So now p points to a. let's say now we want to store whatever p points to, the variable of that, into another integer, b. So we do that right here on line 15. So we dereference the pointer p to initialize integer b as the value of the variable that the pointer p points to. And then now we have no use for p. So let's say, all right, so p has no use. We don't even need to use p anymore. Let's throw it out. So by throwing it out, we just null it out. So we do p is equal to null. Keep in mind, nulling out a pointer does not mean you null out the variable. The variable is still there. You're just making that where the pointer, like so inside the pointer, there's no memory address stored in it. It's just null or 0 stored inside of it. That's one thing to note. A is still alive and well, so it's still inside the stack. But yeah, so let's say we don't need p anymore. We nulled it out. There's no need for it. And this happens a lot. And let's say, all right, somewhere in your code, you forget that you didn't use it anymore and you nulled it out. Now you want to dereference it and let's say print it out. So right here, I'm printing it out on line 20. And when I dereference it, it points nowhere. So it gives me a runtime error, a segmentation fault. And that tends to occur a lot. It's a common error in a lot of software. So that's one thing to be careful about. But yeah. So here's a quick review, and I made this really quick. If you guys want to take a screenshot of it, I recommend you guys do. This is just quick 5 pointers on how pointers work. No pun intended. But yeah, so pointers allow you to access a variable indirectly. So you don't need to access the variable itself. You can point the pointer to somewhere and just access it through using the pointer. So you use type name *p to declare a pointer. So type name either an integer, char, boolean, whatever. Then you use also *p to dereference it. Don't mix those up together. And then you use &var or variable to get the memory address of a specific variable. And then when you dereference a null pointer, it will cause a segmentation fault. So that's something to be very careful about. Are there any questions at this point? Just making sure. All right. So let's jump into some actual examples. So here, let's solve some examples. I'm actually solving examples from Cracking the Coding interview. We're going to be solving 3 problems. And if you guys want to solve them on the side or just look at me solve them, it's all fine. I decided to use Replit, to be honest with you, because I didn't want to use a specific IDE in case somebody doesn't have an IDE or whatever, just because sometimes getting a compiler installed and whatever is a bit of a pain depending on what you're running. So I'm just going to do it on Replit, and I guess if you don't have a C or C++ anything installed, just use Replit. So the first question is linked list and nano on the moons. Oh, alrighty. I would use it. You know what? Actually, on the moons, I do have my Vim config, so I could use that. Actually, that's an interesting idea. So to get all the 393 people to start out using it. But anyways, I'll just use Replit for now, just so I don't have to log into moons, because I'm not even on my main computer. But yeah, so I'm assuming everybody here knows something about linked list and how a linked list is structured. And that's one thing that is that, because I assume here we have second-year computer engineers and second-year computer science. So one is already took linked list in CPS 125, and the other already took linked list and are more advanced in data structures than the NGs. Anyways, so what we're going to do is we're going to solve this question. So let me stop sharing and I'll share my browser. Alrighty, share. Perfect. Okay, so let me double check on the screen. I'm hoping everybody could see my browser. All right, so the question asks us to remove, so here, let me type it out. So what we need to do is we need to remove dupes in a unsorted linked list. So first off, what we need to do is we actually, it's stuck in a cave. Anyways, but yeah, so first thing we need to do in this, we need to actually implement a linked list first. So what we need to do is I'm going to implement two things. I'm going to implement the structure of a node, pushing and printing a linked list, and then we're going to solve the problem. And we're going to use this because all three questions are linked lists, so we're going to be using all these functions. So first off, people that, okay, so 393 people, bear with me. Think about this like a class in other programming languages that you use, but it's called in C, there's no classes, so use a structure to store your data. But yeah, let's get started. So we have a struct, and we're going to call this node. And inside that structure, we're going to have two variables. So we're going to have an integer, and that's going to be a data, and we'll initialize this, let's say, to -1, and that's what's going to be stored inside the node. And then inside the node, we also will be storing a pointer to the next node, and we'll initialize this to null, null pointer, or 0, because right here I have on C++, I'm just going to use null pointer. Sorry, but yeah. And now what we're going to do is we're going to be we're going to write the function to push something onto the like to push things onto the next node and whatever. So one thing to note is this might get a bit confusing because we're going to be using double pointers in this case, and I'll explain why after. So there's something called a double pointer, and a pointer, a reference to a pointer. So one way is in C++ and the other in C. So we're going to do the C first, and then I'm going to explain the C++ way, but they're both the same thing. But yeah, so we're going to have a function void, and that void is going to push something onto the, let's say, head. So we have node, and the arguments are going to be just the head and the new data. But the head needs to be a pointer to a pointer, because let's say we need to switch up, because let's say we have a linked list right here, a node. When we push something onto a linked list, we push it from the beginning. So that head, like the new node, becomes the new head. But as you guys know, pointers are also copied. The address is copied, so we can't really alter the address where the pointer. Well, yeah, we can't alter the address where the pointer points to. So what we need to do is we need to actually have a pointer to a pointer. So let's do that. So we have a pointer to a pointer head, and here we're going to have new data as our other argument. And what we're going to do is, first off, we're going to create a node, and we're going to call this new node. And right here, we need to allocate on the heap the new node. If I'm hoping everybody here understand the heap and stack. If you don't, we're just allocating a pointer. Anyways, so right here, there's two ways to do this. We could do this using malloc, which is the C way, but I'm going to do it in C++ here just because it's easier and easier to understand for the people that have not advanced in C yet, such as the 393 people. And the people also in 125, I guess they already know how to do malloc, so there's no need to worry about that. So right here, we initialize new node, the pointer to new node. So all the Java people here, all the CS people will understand this. Looks the same like Java, except that there's a pointer right here. Anyways, let's continue. Then we go new node, and we point that to data. And what we need to do is we need to store inside the new node the data of the new node, the new data right here that we passed. And just one thing to explain right here, this arrow is exactly like me doing this, because again, if you guys remember, we need to dereference the pointer to use it. Because right here, if I just call the dot operator, I'm calling the dot operator on the memory address itself, which that cannot be done. So I need to dereference it. So this is a quick way to dereference it, or I could just simply do this. I could dereference it first inside brackets, and then just do dot data equals to new my arrow keys are messing up. Anyways, so we could do this or this, but obviously you guys would prefer using this because this is much easier. So just remember that. So I'll keep it here just so everybody understands what I'm doing here with the arrow operator. And then we're going to point that new node, that new node's next to head. But we can't just put head because it's a pointer to a pointer. So when we call head, we need to dereference head to give it the address of the head, like to give it the address where next should be pointed to. And then all we do here is we do head, we dereference head again, and we point head to the new node. And that's pretty much it. So right here we pushed a new node to the linked list. I want to make sure everybody understands this. I know double pointers can be very confusing for people just starting out. So it's all fine. Just let me know if you guys have any questions. All right, I guess I'm safe to continue. I'm just going to do this in C++ real quick. And I'm going to use it by pass by reference. I'm just going to call this CPP. It doesn't matter which one we use. And what we do here, it's a pointer to a reference. So we do this right here, and that's pretty much it. And right here, because we did that, we don't need to dereference anything. Yeah, so that's it. So both are fine. It doesn't really matter which one you use, depending on what language you're using, actually. But yeah, so we just we create the function push, and now let's create the other function, which we're going to print out the list, so just so we could see the answer visually. So we're going to have a void function, and we're going to call this print list, and all we need to give it is a pointer to the node. So we're going to call the node head. And what we do right here is all we need to do is check if head is not a null pointer, points nowhere. What we could do is we could do head not equal to null pointer, or what we could do is just call while head, because anyways it checks if it's valid or not. So it's a simpler way to do it. And now all we do is, let's say we want to print this out, so we're going to do std cout, and this is like printf, but much better. I'm sorry, all the C enthusiasts out there. Yeah, I love cout, so I want to be using it. So it's just me printing it out. So I'm gonna dereference the head and call the dot operator on the data, and right here we printed out the data, and then we're gonna print out an arrow to signify that it's linked somewhere as such, and that's it. So right here, all we do is, obviously everybody here that took data structures or took 125 to traverse a linked list, all we do is we do head is equal to head next. And that's it. So right now, when we call this function, it is going to go through each node and print out the data. And then when it's invalid, so when it's a null pointer, it's going to stop and exit out of the function. So what we can do here is actually just to signify that we're pointing to a null pointer. I'm just going to have an std out here, and I'm just going to put null pointer. And what I'm calling right here, for the people that have not done C++, this is just an end line, so it clears the buffer and the output string. But yeah, so this is printing the list. Now let's get to solving the problem. So there's two ways to solve this problem. So we need to remove a duplicate inside a function, inside of a linked list. And because this is not a data structures specific workshop, so I'm going to give you guys the answer right away. We're not going to think about how to solve this really. We're just going to, because I just want to apply pointers right here, and I found linked list to be the best thing. Let me make my screen bigger. I just noticed my screen is tiny. All right, so what we're going to use is we're going to use a set. So so everybody in 305 should know what a set is. But for the people in 125 or like the NGs, second year NGs, what a set is, it's you insert into a set, and it has almost if you search for something inside of a set, it has the best case O of 1 or O of the worst case being O of n. So solving this most efficiently, you would use a set. And in here, I would need to include not any unordered set. And that's what we're going to be using. All right. So to solve this problem, what we're going to be doing is we're going to have a function, and we're going to have this as void. And what we need to do is we need to remove the dupes. So all we do is, let's call this function remove dupe. And we're going to pass it a pointer to the head. And what we do right here is, first off, let's say we need to initialize an unordered set. Oh, what did I just do? Yeah, an unordered set. And what we're going to do, for simplicity's sake, we're going to say that we're just going to put, we're going to store integers inside the set. And we're going to call this, let's say, the buffer. I'm not sure why it's giving me error. Let's call this buff. Why is it giving me an error? Oh, whoops. My bad. Anyways, yeah. So let's continue. So right here, we initialized we declared a buffer, an unordered set. And we're going to have two things right here. We're going to have a pointer, and we're going to call this previous. And that's going to be a null pointer because we don't have a previous to the head. And we're going to have another node, and we're going to call this current. So we're going to call it cur. And that is going to point to the head. So what we're going to do is we're going to do while current to make sure that current is valid. And we're going to simply do, we're going to simply just find if the current node, the data of the current node is stored inside the unordered set. If it is stored inside the unordered set, we need to delete it. So what we do here is we do buffer, and we call the find method onto the unordered set, and we find the data. What's the problem here? Yeah. And then what we need to do right here is we need to check if it's not equal to the buff.end. And this is just a way to find things in C++. Buff.end is an iterator to the end of the buffer. So if it's not found, then it would equal to the buffer end. And right here, we just need to delete the sorry, yeah. So just delete. One sec, am I messing up? Yeah. So right here, if we find the data. Oh, sorry. Actually, let's do this in a better way. Let's see if it's, so if it's not inside the buffer, what we're going to do is just, we're going to insert it. Actually, that's a better way. So we're going to insert this, we're going to insert that data inside the buffer. So we're going to do current data, and we just insert it inside there. And we're going to make the previous equal to current. And then right here, just so we don't have an infinite looping case, we're going to do current is equal to current next. And let's write the else statement now. So else, if it's found inside the buffer, what we're going to do is we're going to point the previous, okay, in the previous next to the current next. So because current being a duplicate. And right here, we can delete current. And we deleted, sorry. So right here, we deleted current in memory. So current does not exist anymore. Yeah. Actually, there's no need to do that anyways. I'm not going to go into explaining that, so let's forget about that. But yeah, and that's pretty much it. So we just wrote the, because there's two methods in C and C++. One is free and one is delete. Anyways, so right here, we did all of this. Now let's test it out. Actually, let me remove this. So all we do right here is to initialize a linked list. Let's start right here. So first off, what we're going to do is we're going to have a node, a pointer to a node, and we're going to call that the head of the pointer. Actually, let's initialize it right now. So we're going to call this new node, and let's do this much faster. I'm just going to add an initializer for a node, and we're going to accept an integer, and we're going to accept an integer a, and we're going to initialize. And this is how we initialize things with initializer lists in C++. What we're going to do is we're going to do data is equal to a. And then that should be it. Sorry. Actually, why am I messing up right here? Yeah. Oh, my bad. Anyways, so right here, we just initialize the data right here with a, so we could do this. So we can pass inside here, let's say 5. And then what we're going to do is we're going to also do head next is equal to node, let's say 6. And let's just paste this in. So we're going to have some test cases right here. We're pasting this in, and we're going to have, let's say, 2 6s, a 7, an 8, an 8, a 9, and a 7, let's say here. And we're just going to keep going. Next. Also, sorry for the weird typing. I'm actually using my laptop's keyboard, so that's why I'm not on my main computer. But yeah, so let's make sure that everything runs. Where is this going on? Yeah, so let's just switch this up like that. All right, because we changed that. All right, perfect. So right here, we just made this linked list. And when we print out that linked list, let's pass head into it and run it. We get this as we initialize it right here, 5 6 6 7 8 9 7, and then the end it points to a null pointer. So let's say here we want to remove the duplicate just to test out what we did right here. What we do here is we pass in head, and then we'll print the list again. As you can see right here, it removed all the dupes. So we had 2 6s, we had a 7 here and a 7 at the end. It removed them all. So yeah, congrats. You solved your first, assuming it's your first linked list problem in C or C++. But yeah, so this is the first question. I'm hoping I'm not, yeah, I think, let's see. Do we have time to solve the next question? All right, let's solve the next question, and I guess that's it. The next question is pretty simple, so we'll solve that, so it shouldn't be a problem. So the next question is return the kth element to the last. So we would return, let's say, the third last element. And how we do this is it's pretty simple. So let me explain this for you. So let's say we have this right here, this linked list. So if we iterate, let's say we want to return the third last element, what we do is we actually iterate k times through the linked list. So 1, 2, 3, and we're right here. And then we point a pointer to 6. So let's do this. So we point a pointer to 6, and let's use this as a signify as a pointer. And then let's have another pointer actually iterate. Then after we iterate the k times inside the linked list, we need another pointer that starts at the beginning. And what we do is we iterate that pointer while iterating this until this reaches a null pointer. So let's say we iterate this once. So now we're 7 and this is 6, right? And then 8, let's say, let's count this. So we iterate for it to reach a null pointer. We iterate 1, 2, 3, 4. Now, if we iterate here 1, 2, 3, 4, the next element is actually the third last element. And that's how you solve this problem. So let's actually implement that right here. So let's copy this over and put this right here. And to do this, all we need to do is we want to return the nodes. So what we're going to do is we're going to do node, and to return, oh, actually, I didn't talk about this. To return a pointer, we also, instead of, let's say, putting an int, we could, let's say we're returning an int. So we would return an pointer to integer, and that's how we do it. And then we write the function name here. In this case, we're returning a pointer to the node. So we're doing node asterisk, and then we're putting, let's say, end element. It doesn't really matter what we call it here. And then the arguments is going to be the pointer to head and an integer k. And what we do right here is, as I've said right here, we need 2 pointers in this case. So we need a pointer, let's call this pointer 1, and we're going to point this to the head. And we also need pointer 2, and we're also going to point this to the head. And what we do is, like I said, we iterate through the first pointer k times. So let's have a for loop right here. For auto I. In C, you just use integer, but I let the compiler decide what I wanted to use. So yeah. So then I would use I is, while I is less than k, I plus plus. And then here, what I do is just if pointer 1 is valid, because we also need to make sure that if pointer 1 is valid, because if we iterate through here and the linked list is, let's say we give it 7 here and the linked list is this long, it will go to a null space, and at one point it will try to dereference a null pointer. So we always need to check when using pointers, we need to double check that it's valid. So right here, we're checking if it's valid. And when it's valid, we just do P1 is equal to P1 next. And then if it's not valid and we're still inside the loop, actually in this case, we should just return a null pointer or 0 or null. That signifies that there's no kth element in that linked list. So yeah, so now we iterated through it. Now what we should do is just, like I said, iterate the next pointer while iterating the second pointer till that second pointer reaches a null pointer. So to do that, all we need to do is do while P1. So it checks if P1 is not a null pointer. And we do just P1 is equal to P1 next. And then we do P2 is equal to P2 next. And then all we do is we return P2. And that's it. We solved it. So let's do this on this list. So stdc out, and I'm just going to print out the node, the data of the node. Actually, no, I don't want to do it just in case we have a null pointer. So let's do, let's say how we're going to test it out. All right, so let's do print list, and we're printing the head now, and let's do this actually on the head. So we're going to do, what did I call the function? I called it, sorry, print list. And I called this end element. Oh yeah, my bad. And then we're going to pass into it head, and we're going to, let's say, what should I pass to it? Let's say the second last element. So when I do that, it actually should return this node. And then what we'll do is it will print out 8, 9, and a null pointer. Let's run this out. And yeah, so we should get 8, 9, a pointer, 8, 9, 8, 9, and then a null pointer. And this is returning the second last element. Let's do this actually on the one before. So let's not do this right here. And let's say we want to return the 1, 2, 3, 4, 5, the fifth to the last element. If we do that also, it should do the following, and it returns this. So it would be 1, 2, 3, 4, 5, and it returns all of this. And yeah, that's pretty much how to solve it. Does anybody have any questions about this problem? or like any other problem? I guess everybody's fine. But yeah, so I guess time is up. We don't have 4 minutes. Oh, can you explain double pointers again? Yeah. Let me go back here. So in this case, actually, the reason why we're using a double pointer is if we used one pointer right here, and actually, sorry, yeah. So let's say we used one pointer right here, and we did this normally, right? As we do this, what happens right here is when we, this is all fine right here. All of this is fine because this is the next node right here is going to be initialized with the head, with the address where the address inside head, which is the head node. So this line is fine, but when we get to this line 20, we cannot modify where the pointer points to, because if you think about it, what's happening right here, head is also being passed by, is being copied. If you guys remember when I said there's difference between being copied or by reference or by pointer. So right here, it's like me having, it's just me having a number. So me having the address right here. So let's say if I do this, so I would just get head would be, let's say 0x FF67618, let's say, and that is the memory address, and we can't modify this because it's just giving me the memory address where head points to. So we can actually access the variable where it points to, but we cannot change this. So that's why we need a double pointer. I'm not sure if I explained this correctly to you, like if you understood it, but that's pretty much it. Because right here, we need to modify head, as you can see, because if we don't modify, if we don't do this, what happens is the head stays pointed to the original head and it doesn't change. I'm not sure if you get it or if you want me to explain it further. But yeah, so one thing to note, double pointers can be a bit tricky when to use them and when not to use them. And that comes with just solving some problems, some data structure problems with C++ or C. And you'll understand when to use them and when not to use them. It's a concept. It's a bit hard to think about it just normally without doing any practice. But yeah, so think about it in the way where head, the memory address of head is just being passed in and it's copied in, so we can't modify this. So it's like, all right, so we're passing it by pointer, we're passing we're passing, let's say, a variable by pointer, like the argument. Yes, we are able to modify where that pointer points to, but we can't modify the pointer itself to where that pointer points to. So if you think about it right here, head right here, and I'm going to call this head arg, right? And head arg is another pointer. Head arg, let's call this, actually, I'm going to call this P1 head. And that pointer actually points to the head that I passed in. Actually, I didn't call the insert. So if I call the insert right here, what I would do is I would, let me show you how I would call insert. So insert, and did I call this just insert? Oh, I called this push. Sorry about that. So yeah, so when I push this, I need to pass head by reference, even though it's a pointer. So if this was an where is it? If I take this as a pointer, I can pass this like that, right? And I need the next, let's say, a variable here. So I can actually pass it like that if it's just one pointer. But when there's two pointers, I actually need to get the reference. Actually, this is a much better way to understand this. So think about it like that. So we're actually getting the memory address of that pointer right here, because that's a pointer, right? So we're getting the memory address of a pointer to a pointer of a node. That's why it said it's the it's a double asterisk or a double pointer. So right here we have P1 head, and let's think that P1 head is this one right here. And I'm going to call this actually head, and I'm going to call this head original. And so this is a pointer actually. Head points to head original, which we passed in right here. And then head original actually points into the node itself. So that's the, let's say, the like what is going on inside memory with a double pointer. So in that case, if you think about it, if just head original is passed, right? Let's say head original is passed, and let's do this. When head original is passed, I can modify where it points, like I can modify what it points to, but I can't modify where this points to, because if I modify it where, because this is passed by it's passed by value, so it's the address is copied in, so I can't modify this. I can only modify where it points to. Like I mean, I can modify it, but it does not. The modification stays inside the scope of the function. It doesn't happen here. So when I can't see the modification in here, if you know what I mean. But yeah, that's one thing to note. So when I have a pointer to a pointer, I can actually change where this points to, and I could also change where this. I can change this variable, so I can change where it points to, and I can change this variable, so I can change this data or its next pointer. So yeah, that's basically why we're using double pointers here, and it's the same concept behind a pointer to a reference. I hope I explained this correctly, and I hope you understood it. I'm not too sure. I'm not too good with explaining like things without actually drawing it out. So maybe next workshop I should just plug in my iPad and draw out some things if I need to explain them. But yeah, so that's pretty much it. We finished the workshop. We had one more question that I wanted to solve, but I don't think there's time for it. So yeah, let me know if you guys like this and give me feedback. But you can't change the head. Yeah, so I can't change the head. I can change the head original. But yeah, so let me stop sharing. Yeah. So I hope everybody enjoyed this. And if you guys have any questions, you guys can go on the Discord, the DSC Discord, and just DM me, and I would love to ask you guys to answer you guys any questions if you guys want to ask anything about C++. But yeah, I actually like one thing to note. I love C++, so that's one thing that really I have a passion for. So if you also have questions about C++, I'm down to answer. But yeah, so hope you guys enjoyed this. If you guys have any questions right now, I'm going to stay in the chat for 2 minutes because I have a meeting after this. Actually, a meeting at 7:30, but I'm going to stay for 2 minutes if you guys have any questions. Don't ask about JavaScript. Yes, please, do not ask about JavaScript. If you guys ask me anything about JavaScript, I'm sorry, I can't answer it. It will bring down my manhood, to be honest with you. But yeah. No, like JavaScript is fine. But yeah, don't ask me about it. C++ for chat ++. Yes. Thanks, Alan. Yeah, thank you. But yeah, so let us know using the form that was posted in chat. Oh, yeah. No problem. Voice as soothing as Tony's. I don't think you can compare me to Tony. Like, the guy is up here, and I'm like down here, man. There's no way. Yeah, I was only able to join here at the end. Yeah, the VOD will be saved. Actually, oh, hold up 1 second. Let me show you guys some cool stuff. Because you guys asked me about some C++ stuff. So here's actually one of the first books. Actually, no, this is the first book I read. No. Which one? Yeah, this is the first book I read actually about C++. That made me fall in love with it. And then I read this. I don't like it that much. To be honest with you, it was more for beginners. This is a beauty. Like, this is my love. It's really like, it should be called the Bible of programming, to be honest with you. Like, if you never read this or never look, just look through it. Like, there's no need to read this because this is more of a, let's say, it's not a tutorial really. It's just looking how things are done if you forgot things or you're just trying to learn some things really quick. I recommend this book for that. Another book for a tutorial would be C++ Primer. It's amazing. And actually, if you guys, let's go through some of my book collection. Yeah, I guess I'll just go through this. I don't want to be late to my meeting, but yeah. So I have this Effective Java. It's a nice book. I would recommend it for Java programmers. Okay, Java is not for me. So yeah, this is another book, Rust. Beautiful book, beautiful book. Oh, what was the book name that that you said you loved? It's C++ Primer. Make sure you buy the correct one because there's actually one. Actually, I can't type it in chat. But yeah, so it's C++ Primer. Don't buy like C++ using the plus symbols, not this plus, like the word plus, because on Amazon there's C++, there's Primer, and that's really the fake version of it. The C++ Primer itself is actually the oh, the blue one. The blue one, sorry. This one. This is the C++ programming language. It's written by Bjarne himself, the creator of C++. Actually, yeah, it says it right here. I don't recommend this book for a tutorial or learning C++. This is more of a reference, while C++ Primer is one of the best tutorials out there for C++ book-wise, as you could say. But yeah, another thing out of there. Oh yeah, I have the Rust programming language. It's a well-written book. I don't like the language, even though I know it, and I've used it now for quite a while. But I recommend the book if you guys are interested in Rust. It's a well-written book. Actually, we should. Is Richard still here?
Yo, what's up?
Actually, this is turning into. Is he here or no?
Yo, can you guys hear me? Hello?
Yeah, yeah. I think I turned this into a book review after the pointer workshop.
Nah, that's fine. Don't worry about it.
The last thing, operating systems, 3 easy pieces. Beautiful operating systems book for all the second years next semester taking operating system. It's the Bible of operating systems. But yeah. For the real primer, I'm gonna post it inside in the general chat for the DSC Discord. So yeah. But yeah, I guess we're done. I'm sorry, guys. I took you to my book review. I really love my book collection. So to be honest with you, this is how you know a nerd. He would talk about his book collection out of nowhere. So yeah, I sometimes bring up my book collection, my programming book collection, just in a normal conversation. but yeah, anyways, I hope you guys enjoyed it. And yeah.